Okay, hello everyone. My webcam is not working today, but I hope the video is still okay. We'll just get started in a few minutes. Good evening. So today we have a lot of ground to cover. We have to discuss the long run perfect competition, then monopoly, and then oligopolistic competition, which is Cournot, Bertrand, and Stackelberg. So that's quite a fair bit to be covered today. So, I mean, I think the syllabus is like a lot for this week, and I don't think we'll have enough time to sort of cover all the type of examples, but at least I'll try to discuss some of the important examples. But before I go ahead, if you have any questions, please let me know. You can just type in the chat box or something so we can discuss. So today is the last class for this course, and I mean, I know today is not the review session, but still, like, if you have any other questions, I can discuss it. So it will be nice if you let me know now itself, so I can just discuss it before we start. Then I'll get to the questions. Just give me a moment. I'm just setting up my iPad. Okay, no questions? Okay. So let's just start with some basic idea of where we are at this, where at what point of the course we were in. So in the last class, we had discussed the short run cost optimization in a perfectly competitive setting, and we discussed, how you compare with average variable cost and marginal cost, and how the firms take their decide their output decisions, and so on and so forth. So now we come to the long run, and in the long run, the one of the most important features of uh, perfect competition is that it is marked by free entry and free exit, and that is an important assumption. It's not like it's a non-negotiable assumption. So, like, if there is no free entry and no free exit, if there are some entry barriers or exit barriers to firms, then the whole character of the perfect competition changes. It sort of doesn't remain perfect competition in that sense. Just give me a minute. There's a glare behind me. Let me just fix that. Yeah, this is okay. So, yeah, so let's come down to some basic idea of what is long run, equilibrium in a perfectly competitive market. So, what do you think? This is a simple MCQ question. So what do you guys think will be the answer here? Okay, one person has answered. Others? Okay, one more person has answered. Anyone else wants to try? Okay, so there's a whole discussion on this aspect of long run competition. And the whole reason why I have specifically mentioned that they are identical firms, the infinite means very large number of identical firms, and it is characterized by free entry and free exit, is because as long as there is some profit to be made in a market, so we say zero profit, maybe it's not zero, maybe it's a little bit more than zero, just enough for them to sort of survive. But as long as there is any, you know, non-negligible, let's say, non-negligible profit to be made in any industry, there will be more firms entering the market. And as firms keep entering the market, the prices will keep getting lower and lower. And I had explained, somebody had asked this question in one of the previous classes and had explained it also as to why this is. And I think in the videos, there is a mathematical explanation also of why this happens. So, but broadly speaking, even if you just think just from the intuition point of view, maths aside, if you just remember, like, if there is profit to be made, there will be more and more firms entering that industry or that market. And as long as there are firms, as competition keeps increasing, as long as there is a large number of firms, or there will always be some firm which is going to think that, okay, let me reduce my price a little bit more so that I can take the entire market share. Because if your product is something like, we're not talking about differentiated products here, but say suppose all the firms are producing exactly identical product, like say suppose it is something like canvas cloth or something like that, in which there's not much product differentiation anyway. So if there is like one firm is exactly like the other firm, so one firm will think, okay, this guy is selling it at 100 rupees a meter, I will sell it at 90 rupees a meter, and the entire market share, all the buyers will buy from the guy who's selling it at 90 rupees per meter. So this whole process will keep on carrying on, because the moment one guy lowers their price, all the other firms will be like, why am I taking the beating? Let me also lower the price, and let me also make positive profit. Like I'm making zero revenue now, not just zero profit. So this is kind of like how it keeps going on and on until the firms will be driven to reduce their price to the marginal cost, because they cannot lower it beyond the marginal cost. They have to make some, they have to cover their costs basically. If they stop covering their cost, then they cannot produce. So price cannot be less than marginal cost. So each firm will keep reducing the prices, and at the point where price becomes equal to marginal cost, the firm cannot make any positive profit. Now, again, I mean, for all mathematical and all purposes of the syllabus and course, you will always say that the profit is zero and the price is equal to marginal cost. In reality, it will not be exactly equal. There may be maybe just slightly more than marginal cost, but it's not enough for a new firm to enter the market. Just give me a moment. I think my power is not connected. Sorry. I forgot to connect power in my laptop. Just give me a minute. Okay. So is this clear? Any doubts? So the answer is B. No firms will make any profit, which is, and for this conclusion, the necessary conditions are that there is a large number of firms or an infinite number of firms. They are identical, because if the cost structure of some firm is different, if the marginal cost of some firm is different from the other, then obviously you can, if your marginal cost is lower than that of other firms, then you can lower your marginal cost. Now, again, this is also mathematically discussed in the videos as to if you're able to reduce your marginal cost somehow, you will have to compensate for it in some other way. Now, of course, there are exceptions in the real world. There may be a way that you have found some way to reduce your costs further, right? So that is not the type of exceptions we are discussing in the, for the purpose of this particular course, at least, because this course is like at a very basic level, right? So those things will make like it a lot more complex, and you won't get very neat calculations with all of that. Anyway, and that's not perfect competition, right? We're talking about perfect competition. So there's always going to be infinite number of firms. There may be some, in the chapter on costs, I think you take the example of firms with different cost functions. So that may be different from one question to the other. But broadly speaking, when you're asked a general subjective question like this, you will assume when they say identical, it means they're identical in the product as well as in the costs. Input and output, both they're identical. And they're characterized by free entry and exit. So with all these conditions satisfied, no firms will make any profit. Is it okay? Okay, so let's come to the next question. This is a question I've taken from the book by Andrew Spotter, I think. Andrew Spotter. And this is not a solved question, but I think you can probably find a similar solved example in the book also. So yeah, this one is not a solved question, but you can find a similar solved example in the book. So I will just give you a few minutes to solve it, and then we discuss it. Okay, did anybody try, or should I go ahead? Okay, if anybody is working out the answer, I will just give it a few minutes. Okay, somebody has. So I have actually not solved this question beforehand, but we can solve it now anyway. So, okay, let's see. Open the question here. Okay, so the question is question 2, right? Yeah, so the cost function is given by QQ minus 4Q square plus 6Q. So this is each firm's cost function. So first we will find the marginal cost, which is 3q square minus 8q plus 6. So in a long run equilibrium, price is equal to marginal cost, which implies 3q square minus 8q plus 6 is equal to P. Now the profit of the firm is given by P into Q minus C, right? So the profit is equal to, this is 3q square minus 8q plus 6q minus q. So some things will cancel out. Q, Q, Q. This gets cancelled, right? Okay, plus 4q square minus 8q square. No, sorry. That was okay. 3q cube minus q cube is 2q cube. This is minus 8q square plus 4q square, right? So minus 4q square plus 6q minus 6q. Okay, so for profit maximization, the firms will do d pi by dq, which is 6q square minus 8q is equal to 0, in which case you can take 2q as common, q minus 4 is equal to 0, q is equal to 0, comma 4. This is the answer I'm getting. I think somebody had posted a different answer. How did you get your answer? Can you check if you made some error or if I've made some error? Both are possible. It's possible I can also make a mistake. Let me check if I have made any mistake. Okay. So this is what I'm getting. So it will not choose q equal to 0. Price is equal to, what is the function for price? Yeah, 3q square minus 8q plus 6. So you can plug in the value of q minus 8 into 4. 48 plus 654 minus, let me just use the calculator. So I think someone.
Ma'am, I think the q
Yes.
minus 4 is wrong, ma'am. I think it should be 3q minus 4.
Where will it be 3q minus 4? Why will it be 3q minus 4?
Ma'am, when you put the differential is equal to 0.
Okay. Yeah, got it. Okay, thanks. Yeah, because I think the answer is coming a bit high. Yeah. Where did it go? Okay, so q is equal to 4 by 3, so it is 1.33 something. So p is equal to 3q square minus 8q plus 6. So, I mean, you can calculate the price from here now. Somebody sent me a file. Okay. Okay, you have sent the question on the chat. I'm not sure why. So, what is the question exactly? Okay. So your question is 1 minute. I'll come to your question. Let me just solve this first. Yeah, can somebody just calculate this? It's just my calculator is taking a long time. If you have a physical calculator, it will probably go faster. So. Six. Okay, 8 into 4 is 2 by 3. It's still not right. Something is wrong somewhere. Actually, if you take marginal revenue equal to marginal cost, you will get the same condition. So somebody posted 12. I don't know what is 12. I mean, 12 is what? 12 is the answer for what? The problem is solved it in my head and I didn't solve it on paper, and this is kind of what happens when I solve things in my head. Okay, so price is somebody has solved it. Yeah, but it doesn't look very convincing, but I can't find any error in it. So yeah, I mean, I can see that you can solve the maths a little bit. It's just basic calculator calculation. So you solve it, whatever answer you get, that is the price of P. I'm just wondering, find minimum value of. Yes, you can do that also. They will both, I think, lead you to the same solution. Okay, now let's do it that way first. I mean, let's do it that way also. Maybe I've made a mistake somewhere. Actually, in equilibrium, you will have average cost equal to marginal cost. So we can try it that way also. I think that is how I originally solved it. I'm sorry, I'm a bit sleep deprived, so uh, I'm not working like I normally do. Minus 4Q plus 6. So yeah, I think this will probably give you the correct answer. What I have solved, price is equal to marginal cost, but somehow I have probably made a mistake somewhere, which is why we are not getting the proper answer. So I'm erasing this for now. If I find my mistake, I will post the correct solution with the correction again. But just to avoid confusing everybody, I'm erasing this for now. I have made some error somewhere, but I can't immediately see it some right now. So let's do it this way, the way you are saying. Average cost will be equal to marginal cost, and average cost is q square minus 4q plus 6. So q square minus 4q plus 6 is equal to 3q square minus 8q plus 6. 6 gets cancelled. So we're getting the same kind of answer, but okay. It's q square minus 8q plus 4q minus 4q is equal to 0. So yeah, you can take. So this is how you were getting q equals 2. So just for the sake of keeping it all mathematically correct, you should always report 0 also. So like 0 will not be the answer here, but you should always write it, because in some places it may be 0 also. You never know. Okay, where is the price function? Yeah, so let's calculate price from here. I think now you will get what you are posting. Because when I had solved it earlier, I also did not get the answer I was getting. That's why I thought it's probably wrong. 15 minus 16. Right. 2. Okay, so I think this is the correct answer. Yeah. Yeah, I think this is the correct answer because as somebody also pointed out, I started doing profit maximization, but in a perfect competition, that actually gives you the same condition. So sorry about that. There was a little bit of confusion there. I kind of lost thread of the question. Okay, so I hope it's clear. So in the long run, the main thing is that the point at which the firm is going to operate, price will be equal to marginal cost and the average cost. So marginal cost is equal to average cost is equal to the price. Okay. Now we can move to monopoly. And this is the simpler question which I found. I think this is it's a solved problem in that same book by Andrew Scottel. So if this time, hopefully, we won't have a problem. So I'll give you a few minutes to solve it, and then we'll solve it together. So let's solve this question. So the main thing to note here is that in the first part, it asks you what is the what is the socially optimal price and quantity of water? Right now, the main thing to understand is that the socially optimal outcome happens in the case of perfect competition. So whenever you are asked like a question where you're asked to compare a monopoly or an oligopoly, and you're asked to compare that with the option which maximizes welfare or which is the most socially optimizing problem or whatever, some wording like that, you should understand that they're referring to perfect competition because the maximum welfare a consumer makes is in the case of perfect competition. So let me just open the question again. So you're given that on Groundhog Island, there is only one source of clean water. The well is owned by Mr. Robinson, who bottles the water and sells it. The average cost is equal to marginal cost, is given as 10 for one jug or one bottle of water. The demand is given as Q is equal to 100 minus P by 2, where Q is the number of bottles or jugs of water, whatever. So the first part is the socially optimal choice. Socially optimal case is pretty straightforward. You will just do price is equal to marginal cost is equal to average cost, which is what we just did, right? So the average cost equal to marginal cost is already given to you. So price is equal to 10. And from here, you can calculate Q in a very straightforward way, which is equal to 100 minus 10 by 2 is equal to 95. So this is kind of like, for your reference, that's why I included this part just for comparison's sake, that we know what the case would be if you were in the case of perfect competition. Now, in the case of a monopoly, the basic the basic identity where the firm equates marginal revenue to marginal cost remains, but the key difference is that the market demand is the firm's demand, the demand which the firm is facing. So a monopolist faces the entire market demand, right? So in this case, we will first find the marginal revenue of the firm, because marginal cost is given to us. What we need is an expression for the marginal revenues. First, let's calculate the revenue, which is P into Q. Revenue is equal to, or let's write the expression for P first. So we're given the demand function. So 2Q minus 200 is equal to, sorry, let's put this aside, 200, right? Take it this side, take this side, yeah. So this is the price, inverse demand function. So revenue is P into Q, 200 minus 2Q into Q is equal to 200 Q minus 2Q square. Marginal revenue is dr by dq, which is 200 minus 4Q. And in this case, the main thing to note is that the marginal revenue will always be equal to marginal cost, but marginal cost will not be equal to price. You will have to calculate the function for marginal revenue and equate that as the marginal cost. So this is 200 minus 4Q equal to, this is given as 10, right? Yeah. So this is 190 by 4 is equal to Q. Q is equal to, just whatever it is less than what we had before. 47.5. So this is your quantity, and price is the same in both the cases, because price is price is not the same in both the cases. We have to calculate the price. Marginal cost is the same in both the cases, but price will not be the same. 200 minus 2 into 47.5. This is 200. 1 minute, my phone is. Okay, so if we compare this outcome with the perfect competition case, you can see that even otherwise, the price is 105 here, and the quantity is 47.5, which is not at all like good for the society, right? It may be good for the seller, but it is not exactly the ideal outcome for the consumer. So, questions about that? No? Okay, so see the big, huge difference in the quantity and the price. And this is kind of, why you have all these antitrust laws and why monopolies are not the most favored market structure. Like, of course, there are cases of natural monopolies, and the example I've taken is the case of a natural monopoly where, there's a certain resource and there's only one person or one entity or one firm which has access to that resource. So that kind of automatically makes them the monopolist in that situation. Okay, so if you want, I have sort of gone over it in I think as much detail, but if you want, you can still check the solved solution in the book. Okay, so this is a slightly different question where we talk about the elasticity of demand. And I'll give you a moment to go through the question and to attempt it, and then we can discuss it. So in this question, you are given the quantity, the profit maximizing uh, output is 800, and the price is given, the price is 400. You're given the elasticity of demand, which is -2, and you're asked to calculate the marginal cost. So then we will come to the other two questions. If you can calculate the first question, I think the rest of the two questions are fairly simple. So I'll just let you solve it, then we'll solve it again. Done. This is not a very lengthy question actually. Okay, so somebody has attempted solving it. Let's see if it is correct. Open the question. So I have picked just a few questions which I thought could at least to some extent cover the syllabus for this week. But all these books and these questions, whatever I have referenced in the slides, you can find a lot of these type of questions in all of these books. I've mostly referred to Pindyck and Rubenfield, maybe one or two questions from Perloff, and one or two questions from Andrew Scotter. So wherever I've taken questions from Pindyck and Rubenfield, you can find probably a lot more questions like that in Pindyck and Rubenfield, and similarly for Scotter or Perloff. So if you want more practice or if you want a little bit more variety, you can refer to these books. But just bear in mind that I have taken some of the simpler questions because in your case, um, not a lot of complex stuff is uh, given in your syllabus. So I've not taken very complicated things. But if you want to, you are welcome to, try it out. Given epsilon is equal to -2. So now we know this relation, and this is pretty much all there is to it actually. So if you know this relation, or if you know how to sort of derive this relation, then that's it. You've done it. So price is given as 40, and this is 1 plus 1 upon -2. So remember, you have to take -2. This is the place where a lot of people mess up with the sign, but the sign is important. So I'm just going to rewrite this as this, just to, you know, avoid any confusion. Because this formula, we have marginal cost in terms of price elasticity of demand. In this, the epsilon includes the sign, like there's a sign hidden inside of epsilon. So if you are asked, or if you are given the elasticity of demand, don't use it without the sign, because if you use it without the sign, you will get a very different answer, and that's incorrect. So this is your marginal cost. This is kind of what you have been asked, right? You want me to explain this formula? I don't know what should I explain this. I mean, this is derived in the lectures. If you look at the video, there's a entire lecture in which he has derived this formula. If you take the let me solve it. You just take the function for a marginal revenue and marginal cost, and you differentiate it with respect to, I mean, you try the total revenue, total cost, derive it in terms of marginal revenue and marginal cost, where you're taking P as a function of Q or Q as a function of P, something like that. And this is kind of what you get. I don't have it written somewhere right now, and I don't want to experiment right now. Just in the break, let me just read it once. I don't want to write it the other way around. So in the lectures, in the earlier modules, we have used it as that because in some places, yes, because in some places where you were asked the elasticity of demand, it was asked without the sign. But I don't think in the lecture he has taken this as mod, is it? I don't remember. But if you're given it with the sign in the question, you should always use it with the sign, because you, the thing is, if you use it with the mod, you have to know that there will be a sign here. So if you are given marginal cost and price, and then you're calculating epsilon, you will get it with the negative sign. So, you know, I really don't recommend using it with the mod, because many times people mess up with the sign in that. So I would really not encourage you to use it with the modulus, because a lot of times you don't know when to put the sign in that case. Somebody was asking me for the derivation of this formula. I will solve it. Just give me like, I will solve it after the break. I just want to read it once to make sure I'm not doing it. Yeah, so if you use it with the modulus, you have to add the negative. That's exactly what I'm saying. That if you add the negative separately, then you can add it as a modulus. But if you are, see, now if you use the negative sign and you add it with modulus, then you get the same thing eventually, right? So that's the reason why I don't recommend using mod, because then people do a little bit of both. Like what you were saying. You're saying it's used with modulus, but you have forgotten that there was a negative also along with it, which is why I just make it as a general rule to never use modulus and to let the sign be there as is, because sometimes it may not be negative. Not in this case, but not in the monopolist case perhaps, but in some other case it may be something else, which is a bit confusing if you think about it. You have to remember where it is minus, where it is plus. But if you use it as is and you just keep it with the sign when it is given with the sign, as in keep it as negative when it is given as negative, you will not go wrong with that. So yeah, let's move further. So the derivation, it's pretty simple actually. You just have to take total revenue, total cost, differentiate it, and then you just simplify it to get it like this. But I'll solve it in the break. Let me just continue with this for now. Then you're asked the markup. Markup is just Let me see the question again. So the markup is not, calculated in terms of the marginal cost. It's calculated in terms of the price. So here the price is given as 40 minus 20 upon 40. So the main confusion, which I don't know about other people, but which I generally used to have, is that, for the markup, which should you be taking in the denominator, the marginal cost or the price? So the price is what you always take in the denominator, because price is like, a parameter. So this comes out to be half. And let me see what you're asking. If I have some doubt, if mod E is greater than 1 and P increases, what will happen to total revenue? Will it increase or decrease? Okay, I'll have to draw the diagram for that. So I think I had explained this earlier also. It's similar in the case of a monopolist also. In the case of E, yeah, go ahead.
I'm clear about if it is a elastic demand, that is epsilon is more than 1. The MR will be more than 0, it will be positive. The Q will increase and the total revenue will increase if the quantity increases. And if the price decreases, the quantity will increase and the total revenue will also increase. But what will happen if we increase the price, ma'am?
Okay, I'll have to draw it because I don't understand these things in words. So when I draw the diagram, I will discuss it then. Again, I'll discuss this when we calculate the elasticity of demand, and then we can draw the diagram and discuss your question. So actually, I think I had answered your question once before also in an earlier class, if I remember correctly. And you had asked me the same thing, and I remember reading that question and answering it. But anyway, I'll answer it again. Where were we? So all these questions about elasticity of demand, I will take it in a few minutes. Let me just finish this question first. C is, yeah. So the next part of the question is that you are given the average cost, which is 15. This is the average cost of the last unit produced, and the firm's should be an apostrophe there. Firm's fixed cost is 2,000. Now you ask the firm's profit. So profit is equal to total revenue minus total cost. What all are we given? We are given the marginal cost, we are given the price, we are given the quantity, and we are now given the fixed cost also. Total revenue is P into Q minus this is marginal cost into Q plus fixed cost. Price is given as 40, this is 800. Marginal cost is 20, and this is 800. Fixed cost is 2,000. So this is 3,200, and this is 1,600 plus 2,000. I need to find my calculator. So this, wait a minute, I messed up somewhere. Okay, sorry, we won't take it like this because I'm sort of adding it 2 times. So in this case, because we are given the average cost, The main thing you have to do is that if you're given the average cost, you can just multiply it by quantity instead of taking. You don't need to take marginal cost because marginal cost is going to be an integral, and we don't have the cost function. So remember, marginal cost is not necessarily equal to average cost. And in this case, we don't have the cost function, so we cannot just simply multiply it. That's where I was wrong. So yeah, so then we have 440 into this is 800. Average cost is 15, and this is 800. So then we will get some normal logical answer. This is 12,000, this is 32,000, so this is 20,000. You understood why what I was doing earlier was wrong? So I was taking it as marginal cost and fixed cost, but that is not exactly accurate because there may be some the fixed cost and all that may figure in a slightly different form in the actual function, the cost function. So we don't have the cost function, but we have the average cost. So average cost into the total quantity will always be the total cost. So we don't need to worry about marginal cost at all. So this is the, yes, the fixed cost data in this particular case is redundant because they've not asked you the producer surplus. But if they ask you the producer surplus, then you will add the fixed cost and report the producer surplus because the main difference, the key difference between profit and producer surplus is that the producer surplus includes the fixed cost also. But in this question, actually, they have not asked you that, so it becomes redundant. But if you are in some way, some place, if you are given um, that question, you will use it for that purpose. Okay, so we have finished question 4, and let's see how many. There's one more question on monopoly, and then there are few questions on Cournot and Stackelberg. And if at all we have time remaining, we can briefly discuss the Bertrand uh, oligopoly. No, for producer's surplus, you will add the fixed cost to the profit. There is a difference between profit and producer's surplus, right? And that difference, again, in one of the videos, he has actually explained this. I think you're not watching the videos. That's why you're asking me all these questions. So if you had watched the videos, you would know that he has explained this in the video. So again, it will take too long for me to go through that entire calculation, but that is sort of how the calculation works out to be, that the producer surplus is profit plus the fixed cost. Okay, so I will take a 7-minute break here. And when I come back, I will just do that calculation, whatever you guys were asking me for the elasticity of demand and your question about increase, decrease in price and all that. Okay. All right. I'll be back in not 7, actually, I'll be back in 10 minutes. So yeah, I stopped the screen share because I was trying to find the original place where I had explained this part about elasticity and price increase, decrease, blah, 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 all that. So uh, if you see in this diagram, it's not exact and it's not like to scale or anything. But the point where I have marked epsilon equal to 1 is the place where slight change or slight up or down, if you move, it's not going to affect your revenue too much, right? But otherwise, if you see when the price is increasing, the total revenue will decrease if your epsilon is greater than 1. And if epsilon is less than 1, let's add, there's already too much on the diagram, that's why it's avoiding adding more. But here, if you see the price is decreasing, say suppose here, oops, come on. I don't know what the hell is wrong with this thing. Okay, so yeah, so that's the problem. It's not changing the color. Something is just weird about this whole thing. Okay, let's pick this color since we've not used it. So
Ma'am, is it in the monopoly case, ma'am?
I'm just explaining in general right now. Your question is specific to monopoly.
Yes, ma'am.
Okay, what is your question?
Ma'am, basically, if the demand is elastic, that is epsilon is more than 1, ma'am, then we know that
Yeah,
MR will be positive, ma'am. Now, ma'am,
yeah.
what happens if the price increases, ma'am?
If the MR is positive and the marginal revenue is positive, if the price increases, is that what you're asking?
Yes, ma'am.
Okay, I will have to think about it because I can't immediately say what will happen.
Because, ma'am, I am sure about that. In if the demand is
I'll have
elastic,
to, okay. Yeah, go ahead. Mhm.
if demand is elastic, the MR will always be positive, and if price decreases, the quantity increases, ma'am, and the
Yeah,
total revenue will also increase
yeah,
in a monopoly case.
okay.
So, ma'am, but what happens if the price increases, ma'am? Logically, if the price increases and the monopoly is there, and the demand is elastic, that means, ma'am, the quantity should also remain the same,
I
if
don't
not
think that
increase.
is true, but I will just give me a minute. Let me first answer his other question. If you're not asking about the general case, you're asking in the case of monopoly, I will have to solve it because what you're saying is just a very general thing. It's just better to take some numbers and then try and solve it. So let me solve it that way. First, let me address what this other guy was asking, which is derivation. And from here only, I think your question can probably be answered. So what we are trying to do is general, this thing is that what we're trying to do in general is we are trying to maximize pi, right? That's always the purpose. For this is the monopoly case, okay? For a monopolist. So in this case, you're writing P as a function of Q multiplied by Q minus cost, which is sort of, I think, assuming the cost is given to you as a function of Q. If your cost is just given to you in terms of marginal cost, you can just take it as marginal cost. But for now, we are going to take this as a cost function because this is a general case. So for maximization, or let me write this here only, maximize over Q. So when you do the maximization, you will take the first order derivative, which is P to Q into 1 plus You have uh, this is when you take this, and then when you take this, it is q into dp by dq minus this becomes your marginal cost is equal to 0. So from here, you can derive marginal cost is equal to P plus Q into dP by dQ. If you take P common out of this whole thing, it becomes 1 into dP by dQ into Q by P. And this is the familiar term we have. Price is equal to 1 upon Q by P dQ by dP. And this expression is what we call as elasticity of demand. So this is one. So this is how you get this. Now, what you're saying is that in the case of elasticity being greater than 1, what happens if the price increases? That's what your question is.
Yes, ma'am. Ma'am, firstly, just one thing, ma'am. Ma'am, is
Yeah.
the price elasticity of demand same in both the cases? In
In what
monopoly as well
cases?
as,
See,
ma'am,
the
in a,
function, the expression is the same, because here we have not made any other assumptions, right? We have just taken total profit and we have maximized, I mean, we have derived the expression for profit maximization, for which gives us this whole thing. No, we have not equated it to price here, right? Here we have
ma'am,
derived okay, what are you trying to ask?
ma'am, this derivation I'm okay with. Ma'am, I was just
Yes,
solving some questions yesterday. So a
okay,
doubt came to my mind was the price elasticity of demand, ma'am. Is there
yes.
any difference in that in case of a perfectly competitive market vis-a-vis a monopoly market, ma'am?
Uh, so in the case of a perfectly competitive market, you will generally have a perfectly elastic demand and supply. But in the case of a monopolist, I think it will not be so. Let me just check. There is a difference, but I don't remember it offhand like that.
Okay,
It's
ma'am.
not there. Is it not there in the? Is it not there in the video? Which?
No, ma'am. Ma'am, I've tried going through
Okay,
both the videos again. So,
okay,
ma'am,
okay.
what,
Yeah,
ma'am?
I'll
I
have to
just,
think about it. I know there is a difference, but I don't
ma'am,
remember it exactly offhand right now. I'll have to look it up. And
ma'am.
if you want, I can let me finish speaking.
Sorry,
So if you want, I can look it up, and I will post the difference or the the comparison of both in the notes in the handout. Yes, now you can speak.
ma'am. I'll email you a certain comparisons that I have made, ma'am. I'll
Okay.
request you just look through it. If they are fine, let me know. And in
Yeah.
that, in pencil, ma'am, I've written three of my doubts. So I'll
Okay.
request you if you can solve that, ma'am. Yes, ma'am.
Yeah, sure. You can
Thank
just
you, ma'am.
share that. Just share it with me over email, because it will require, because what you're saying right now is a very general thing, right? I will need to solve it and I will need to look at the equations to understand what your exact question is and how like in what way you were trying to compare the two. That is the thing. Because like you asked me, I mean, it's not like I've rote learned everything, right? When I sit down, when I apply myself, then I solve it and then I figure it out. At least in my limited
Understandable, ma'am.
experience, I don't think rote learning anything in economics works. So, yeah. Anyway, okay. So
Thank you,
please
ma'am.
send me the question, and even I will look up at my end, because I remember there is a difference, but I can't exactly remember what it is right now. So let's move on. This is a slightly more difficult question, but I think it is relevant question. It's possible that you won't be asked questions of this type in your you know um, your test or exams or whatever, but it still kind of helps to go over it once. So I'll give you 2 minutes to I'm trying to find the question actually. This is question number 5. Yeah. Yeah. So I'll just give you 2 minutes. Please solve it. It's not very complex, and then I'll solve it. Like Okay, so does anyone want to attempt and just tell me what the approach will be for this question? How will you approach these kind of questions where um, you have two separate factories or two separate places where the firm can produce and the cost function for both is separate? In this case, you're given the marginal cost, but it you may just be given the cost function. So if you have a market demand and you have the cost functions of two separate, or it means not necessarily be two, it can be any number actually, but just for the sake of simplicity, there are two separate factories where a firm can produce, then how should the firm decide what should be the distribution of Q1 and Q2? So uh, so what I'll come to your question. So what the firm will do will be like, now it has to choose some quantity Q1 and some quantity Q2 for each of the two factories. Now you can see that the marginal cost here is not constant. If the if the marginal cost was constant, this problem becomes like a whole lot simpler, and it's possible that you will encounter those kind of questions for now. But just assuming that the marginal cost is not constant, it is a function of Q1 for one firm one, factory one, and Q2 for factory two, then in that case, now if the marginal cost of say for, factory one is higher than the marginal cost of factory two at any level of production, not taking any specific values, at some level of production, MC1 is greater than MC2, then it eventually boils down to why would the firm produce it at factory one at all, right? If it can reduce its costs by shifting to the other factory, then it will obviously do that. And this kind of a juggling, you can say, or adjustment, or whatever you want to call it, will keep on happening until the firm is able to achieve Q1 and Q2 such that the marginal cost of 1 and 2 are both same. Because until and unless that is not happening, if the firm is experiencing higher marginal cost at one place and lower at another place, it will want to shift to the one where it is lower. Why will it want to produce where the marginal cost is high? It doesn't make sense, right? Because eventually the firm wants to maximize its overall profit, not it's not looking at maximizing the two separately, right? Both the factories are contributing the total output of the firm, and it is that total output and the cost functions of both the firms which the firm is going to consider in deciding its level of output and the level of individual outputs of the two factories. But before we do that, what we need to do is we need to first check if both these factories can actually supply the quantity required given the market demand function. So let's do that first. This is, yeah. So let's go to question 5. You have marginal cost of 1 equal to 20 plus 2Q1, and marginal cost of 2 is 10 plus 5Q2, and you're given the inverse demand function, it's 20 minus 3Q, where Q is equal to Q1 plus Q2. Or let me write this here, I'll draw the diagram. Okay, so now let's draw a diagram where we plot the market demand and both the marginal cost curves. So say suppose price and this is Q. So P is equal to 20 minus 3Q, right? So say suppose this is 20 and this point is 20 by 3. Then this is your market demand. I'm not writing the name because it's just going to make it a bit complicated. Marginal cost of 1 is equal to 20 plus 2Q1, right? So it is upward sloping, and at Q1 equal to 0, marginal cost of 1 is equal to 20, right? That is the, uh, okay, somebody messaged something, marginal cost. Yes, I have taken it as 20 only. Or you're correcting your, okay. I'll come to your question. So marginal cost of 1 is equal to 20 plus 2Q1, meaning at Q1 equal to 0 itself, it was 20, and then it linearly increases with Q1. So it is something like this. And we take marginal cost 2. At Q2 is equal to 0, it is 10. So say suppose this is 10. And then it is 10 plus 5 Q2. So it is to this, maybe something like that. So if you see that only the curve for the second firm is even intersecting the demand curve. The first firm, first factory, the marginal cost curve is not even intersecting the demand curve. So in this case, that's kind of what I wanted to highlight. In this case, since lies above the demand curve, for all Q or all values of Q1, it cannot produce given the market demand. So this is, if there was a different market demand function or something like that, then it would be different. But given whatever market demand function you already have, it is lying completely above that curve. There is no intersection with that. Or you can say that, it is touching the curve at Q1 equal 0, which is basically saying the same thing. Therefore, Q1 equals 0 and Q is entirely equal to Q2. So now I think this sort of simplifies the whole thing a lot. Now P becomes equal to 20 minus 3 Q2. So which is why I think if you were trying to calculate something, it would not give you a sensible answer because you will get some values negative and all that. If you don't check for this condition and you try to solve it, you will get very weird answers. So when we take it like this, then we can always look at, the now in this case, then the profit of the firm becomes P into Q minus C of only 2. There's nothing, you assume that, there's no other cost other than whatever is given. So when when factory 1 is not operating, there is no cost from the first factory. So P is equal to 20 minus 3 Q2 into Q2 minus, well, let's write it first as total revenue and total thing. Otherwise, first let's write the expression for total revenue. And then we will equate marginal revenue and marginal cost. We don't need to go that route. So this is P into Q is equal to 20 minus 3 Q2 into Q2. And total cost is only C2. And what we are given is, we are given marginal cost. We are not given the total cost function. We are only given the marginal cost function. So I had simplified this somewhere. So in this case, we'll just leave this like this. What we'll do is we'll first calculate the marginal revenue with respect to Q2. So here you have dr by dQ2, and this comes out to be 20. minus 6Q2. And because only one is operating, therefore marginal revenue is equal to marginal cost of 2. This actually total cost you don't need to write at all. It's just to explain, or let me leave it there. So it just means that the total cost is only the cost incurred from the second factory. There's no cost from the first factory. So in this case, we have 20 minus 6 Q2 equal to, we had an expression for this, 10 plus 5 Q2. Q2 is equal to 10 upon 11. This comes out to be something like 0.9 something, 0.91. And from here, you can calculate the price, which is 20 minus 3 Q2, 20 minus 3 into 1, which comes out to be 17.273. So this is the approach. Now, in this case, we so happened that we had only one of the factories operational, but the general approach is that whenever you have two plants and one company, one firm, you will take the marginal cost of one equal to marginal cost of two, because that is the only condition in which it can operate. And the second thing is you will take the total revenue, which will be a function of Q1 and Q2 in the general case. And you will take the marginal revenue with respect to Q1 and marginal revenue with respect to Q2. And you will equate MR1 equal to MC1 and MR2 equal to MC2, where MR1 is marginal revenue with respect to factory 1 and MR2 is marginal revenue with respect to factory 2. So I hope that answers your question. You had missed something. So MC is already given. I'm not sure why you were asking. So I think you were probably trying to equate it. You will not necessarily need to. I mean, if you equate marginal cost of 1 with 2, you will get the same thing as you will get from equating marginal revenue. If you equate marginal revenue of 1 to marginal cost of 1, marginal revenue of 2 with respect to marginal cost of 2, you will get the correct answer. What you're trying to do is you're equating MR1 equal to MR2 equal to MC, which is not correct in this case because marginal cost is different for both the plants. Did I answer your question? No, you had messaged me. Okay, so let's go to oligopoly. So this is a simple question, just firstly to introduce you to an oligopoly. Which do you think is going to be the case? Yes, so one of you has answered. So in an oligopoly, the main the main condition in which they don't need to really be treated as an oligopoly but can behave like a competitive market is when there is like a lot of firms and when they are not colluding. So if the firms collude or if they start cooperating, then you get a completely different solution. But if there is there's a large number of firms. I'm not saying large firms. I'm saying large number of firms, which means there are many firms. Then you can actually get results which are very similar to a competitive market. Okay. So which of the following do you think is or are true about the Cournot equilibrium? Nobody? Okay, one person has answered. Anything else? So, what is the difference between an oligopoly and, say, a competition and um, a monopoly? That is what will help you kind of arrive at the correct answer here. So, the key difference between an oligopoly and uh, any competition or monopoly, etc., is that there are, of course, there are more than one firms. There may be two. In the simplest case, you can take it as two, but there may be several firms. In your case, let's stick with two. And the firms are deciding their quantities in the Cournot case based on the quantity produced by the other firm. Now, in the case of Cournot, it is based on setting the quantities. So in the case of Cournot, the firms compete with each other. They are competing with each other, but they have to come up with a strategy where they try to figure out how much they should produce based on what will be their revenue, what will be their profit, given a certain value of production level of the other firm. When I say given, I mean not given. In the Cournot case, the firms are kind of um, checking what their response should be if the other firm were to produce a certain level. So in this case, marginal cost is not necessarily equal to the price. It may be, it may not be, because the level of production is decided based on the entire best response, not based on the simple competition case or monopolistic case. And because this is a game, it's, I mean, you're using game theory, so it is a game, between two players. So what you achieve in the end is a Nash equilibrium. And the whole, by definition, a Nash equilibrium is an equilibrium where no party can be better off by deviating from the equilibrium. That it's not a Pareto equilibrium. You have to understand the difference. It's not necessarily Pareto optimal. It may be, it may not be, but Nash is that if in a place in an equilibrium, if it is an NE, Nash equilibrium, no player can benefit from changing their strategy or changing the response. In this case, the response here is their output levels. So B is correct. No firm can benefit from unilaterally deviating from the Cournot equilibrium. Cournot equilibrium is the Nash equilibrium for a Cournot competition. It is the equilibrium when firms cooperate, which is not true because firms are not cooperating. They're competing. It is where the best response curves of the firms intersect. So yes, that is exactly how you actually calculate the Cournot responses, the final equilibrium values, and this is actually, all of this is directly taken from your lectures. This is all discussed in the lecture videos, but I'm not sure why you guys didn't get it. So has everyone actually watched all the videos? If you've not, it's fine. I just wanted to know how far, like, you guys have progressed. So yeah, so the last two videos are Stackelberg and Bertrand. Before that is Cournot. So okay, let's go ahead and oops, let's solve the question of Bertrand and a table. Yeah, so the table is how you calculate the equilibrium in Bertrand. So I don't think I will have enough time to discuss Bertrand today. And if you guys have any question, you can tell me. But otherwise, And there's not really too much to ask actually in Bertrand. Because at your level there is not too much one can vary. And Bertrand is a bit simple in the simplest case. So, but you should understand what is Bertrand and how they set the prices. So, I mean, you could be asked a subjective question on that. Anyway, okay, let's go to question 8. This is the situation where you have two identical firms in an industry, and they are the only two firms in that market. Each of their cost curves. Now, always pay attention to whether you're given the cost curve or the marginal cost curve or the average cost curve. So, in this case, you're given the cost curves, which is C1 is 60Q1 and C2 is 60Q2. And the price is determined by this inverse demand function, which is 300 minus Q, where Q is the market demand, Q1 is the output of firm 1, and Q2 is the output of firm 2. So first thing is to find the Nash equilibrium. This is the Cournot case. And second part is to calculate the profit of both the firms at this equilibrium point. So I'll mute myself for 2 minutes and I'll let you think about it, and then we can discuss it. Okay, so let's solve this. So we are given these things. So what we'll do, let's write the expression for the profit of each firm. P into Q1 minus C1 right? Which is now P. You don't have to write P. You're not given P as a parameter. You have to find P in equilibrium. Okay, you calculated. Good. So you have P given to you here, whatever we have just found from the inverse demand function. And C1 is given as this. So this is your expression for pi 1. Let's write pi 2. This is P into Q2 minus C2. Again, this is 300 minus Q1 minus Q2 into Q2 minus 60 Q2. Now we want each firm to maximize profit, right? So firm 1 can only choose Q1. They cannot choose Q2, right? So what you will get is Q1 as a function of Q2 when you simplify this thing. So let's take for profit maximization is equal to, so you will set this as 0 at the point of maximization. This gives you 240 minus Q2 by 2 is equal to Q1. Similarly, for the other one, so you have Q1 in terms of Q2 and Q2 in terms of Q1. So at the point of equilibrium, these are, you have to understand, these are the best responses of each. Best response function of 1. Similarly, this is the best response function. So if you are ever asked what is the best response function of this firm, this is what you're going to report. This is what they're asking. What we mean by best response function is that the firm basically tries to find what its output level should be, assuming that there is some output Q2 by the other firm. So if Q2 is say 2, what should Q1 be? Q2 is 10, what should Q1 be? If Q2 is 50, what should Q1 be? Firm 1 does not know what firm 2 is producing. Firm 2 does not know what firm 1 is producing. What they do know, or what they have arrived at by using basic economics, is that whatever be the quantity produced by Q2, what should my output be based on that? This is their response function, or their, in this case, because this is maximizing their payoff, this is their best response function. In game theory terms, we call it payoff. In game theory, when we're talking about firms, the payoff is the profit. In some other cases, it may be something else. So don't get confused when I use terms like strategy and response and payoff and all of that. These are all game theory language, basically. So at the Nash equilibrium, the best response of firm 1 given any value of 2 is also the best response of 2 given any value of 1. Now, I don't want to write it too mathematically. What we can do is we can solve these two equations simultaneously and we arrive at the answer, or you can just let me draw it on a diagram. I think that will help understand it even. Say suppose Q1, let's mark some points here. So let's draw the response function of firm 1 first. Q1 is equal to, say, 120 minus Q2 by 2. So Q2 is equal to 0. This is 120. And at the point where Q1 is equal to 0, what you have is Q2 is 240. Sorry, this is 240. Yeah. So this is, you can plot it like this. This is the, oh, it's not very easy to plot on an iPad like this, but something like this. And similarly, if you look at the best response function of firm 2, it is 240 minus Q1 by 2. Again, when Q2 is equal to 0, Q1 is equal to 240. Q1 is equal to 240 when Q2 is equal to, did I do something wrong? Yeah, I think I have drawn this the other way around. Yeah, this, okay, let me redraw this one. Hang on, I drew the other one first, sorry. Q1 is equal to 240 when Q2 is equal to 0. Yeah, what is, did I write both the same or what? What's wrong with me? Okay, when Q1 is equal to 0, Q2 is equal, no, at Q2 is equal to 0, Q1 is 120. Yeah, that's why I was getting it wrong. So this is the first equation. This is Q1 is equal to, and the other one is this one, just sort of symmetrically opposite. This is the equation of Q2 is equal to 120 minus Q1 by 2. So you can see that these are both best response functions of both the firms. This is one's, blue one is firm one's best response function and green is firm two's best response function. So at the point where they intersect, that is the point at which you have an equilibrium, because both are giving their best response to the other's best response. One is also giving the best response and two is also giving the best response. So both are at an equilibrium. Both cannot actually improve their own lot by moving away from this point. So this is the Nash equilibrium point. And you can simplify this because this is a symmetrical thing. You can actually just replace, if you don't have a symmetrical problem, please don't do this. But because you can see both the equations are just very, very symmetrical, and you can see from the curve also, Q1 is equal to Q2 gives the in E. So if you replace this by Q1, what you get is Q1 is equal to 2 by 3 is equal to 80. Q2 is equal to 80. This is what you get the answer. So I think somebody else had calculated it, but they got it wrong. So Q market quantity is 80 plus 80 is equal to 160. P is equal to 300 minus 160. 140. So this is your, you can mark this as the equilibrium quantity and price. Okay. Mathematically, if they are not identical, you have two equations and two variables. You just solve for each. You find the value of Q1 from the first in terms of Q2 and put that in the second equation. Like how you generally solve two equations in two variables. So let's move on to the next question. So in this same scenario, this is the last question for today actually. And I wanted to take this as a comparison case because that kind of makes it more illustrative of how Stackelberg is different from Cournot. In the same question, not 6, sorry, this is question 8. I've written 6 by mistake. In question 8, assume that firm 1 is the leader and firm 2 is the follower, which is, so even though I have mentioned it here, find the Stackelberg reaction function of both firms. And of course, I didn't add it, but you can find the equilibrium values also. But if you are given that firm 1 is the leader and second is the follower or whatever, then it is automatically assumed. I mean, they have, in a way, they have told you that it is Stackelberg. So whenever you are told that one is, yeah, I've written 6 here, this is 8. Okay, let's go to question 9. So some things we can just borrow from here. So for example, we know P is equal to 300 minus Q1 plus Q2. This is anyways going to hold because P is equal to 300 minus Q is equal to 300 minus Q1 plus Q2. There's no assumption here. This is the general case in a market with P price and two firms Q1 and with Q1 and Q2 output. What else is given? C1 and C2 are anyways given to us. And what we found was the reaction function of Q1. Now Q1 is the leader. So what Q1 will do is Q1 will see in this situation, you should know that Q1 knows what Q2's reaction function is going to be, right? And Q1 has the liberty to set its quantity first. In the other case, they were both simultaneously setting their quantities. But in this case, Q1 has the liberty to set its quantity first, which means what it will do is it will take its response function, which is 240 minus Q2 by 2. Or let's not do it this way. Let me simplify it even further. So what we'll do is let's write down the whole profit function again for firm 1 so that we can be clear about what we are doing here. Sorry, 1. This is not troubling at all, right? Let me just see how much we have. Right. So in this case, let's take the price as 300 minus Q1. Oh, wait, I think just give me a moment. Something, some noise in the background. Yeah, I'm really sorry about that. There's something going on. Where were we? Yeah, so let me redo this part. So yeah, what I was saying was is that uh, we derive this reaction function of both the firms. Now, what we can do is we can derive the price as a function of Q1 alone instead of Q1 and Q2. So instead of Q1 and Q2, we just take Q1 and we put the value of Q2 which we got in the response function over here, because firm 1 already knows that this is Q2's response function, best response function, which is 240 minus Q1 by 2. So what I was doing was calculating pi, but this is just a slightly neater and simpler approach. So there's nothing wrong. You can do it that way also. So this is 2q1 plus 240 minus q1 by 2. This becomes 120, so 180, right? Yeah, 180 plus 2q1 minus q1 is q1, so minus q1 by 2. This is price in terms of just the quantity of firm 1. Now we can calculate the profit. This is just going to be a bit easier to simplify. If you do everything together, it kind of becomes a bit unwieldy. 180 minus q1 by 2 to q1 minus 60 q1. Now you can take d pi 1 by d q1, which is 180 minus q1 minus 60 is equal to 0. So q1 comes out to be 20 and q2 comes out to be 240 minus 120 by 2 is equal to 60. And the price comes out to be 300 minus 120 plus 60 is equal to 20. Right? Yeah, I went over it a little bit fast, but this is just simple algebra actually. This is not. Main thing to understand is that whatever response functions you already derived, you can just use that here instead of solving the two as a simultaneous equation in Stackelberg, because q1 has the freedom to choose its own quantity first. What it'll do is it will take the value of q2 from q2's best response function and use that to derive its own, you can call this as residual demand function, inverse residual demand function. And then the rest is pretty straightforward. You write the profit function in terms of q1, you maximize profit for maximization. And you calculate q1, from there you can calculate q2, from there you can calculate price. So this is this is the case of a simple Stackelberg model. In like there are many examples in which you will have differentiated products and which each firm is facing a slightly different demand function from the other firms. So then it becomes slightly different, but the basic approach is still the same. So in this case, we have only one entire market demand is being shared between the two firms. In the case of differentiated products, you will have separate demand function for each firm, but both will be a function of both. So the demand facing firm 1 or firm 1's demand function will include both q1 and q2. Similarly for the second firm, it's the approach is still going to be the same, but the whole calculation is a little bit more complex, so I'm not going into that. And I'm guessing you will probably not be asked questions on that either. So if you have any other questions, please let me know. Whatever else you guys ask, I will look up. Question 9 of week 11. Okay, 1 minute, let me see. Week 11 meaning the one which I shared in the class or which is there in the portal?
Ma'am, one we were doing online, ma'am. You were solving that question.
The one in my slides, you mean to say?
Yes, ma'am.
Okay, let me see which questions. Question 9, but I solved it, no? I didn't solve it.
Ma'am, the time was over and you had told that you will probably solve it and post it online. I don't know, ma'am, whether you did it or not.
No, I don't. Okay, I don't remember. Let me check if I solved it in the. Yeah, I have solved it. See, this is question 9 you're asking, right? So I have solved it. It's there in the. It was uploaded last week itself. Yeah,
It is
because I
there in the
remembered
folder, ma'am.
solve. Yeah, it's all. So I always upload everything immediately after the class. So that I don't. forget it basically. So if you look up the class notes, not the slides, the whatever I write in the class in the board is always uploaded as class notes. This is although if you want, I can explain it. You're given the cost function, and from there you calculate marginal on average variable cost, because this is the short run calculation. So you check for shutdown decision, which gives you Q greater than 0 is the decision point. So, which means the firm will produce at all levels of Q and P. You're given the market demand, and you do the usual price equal to marginal cost, and you get all this. Then you do the equilibrium calculation.
Fine,
So
ma'am.
the
I
rest
think
is
I'll be able to
just
do it, ma'am.
profit. Yeah.
Thank you, ma'am.
Okay.
Ma'am, one more doubt, ma'am.
Yeah.
In the review session that we had in question number 2, ma'am.
Question number 2. Question 2. Okay.
Ma'am, we've had to solve in second option. What is the quantity traded, ma'am? Now, ma'am,
Yeah.
the quantity demanded was 250 and quantity supplied was 400.
Yeah.
So, ma'am, will the quantity traded will be 250, ma'am?
Yeah. How can you sell something which people don't want? People
So,
want
ma'am,
only 250. They're willing to buy, they're willing to pay money only for 250.
Roger, ma'am. Now, ma'am, if in
Yeah.
case the case of like you had discussed the case I had requested for that price ceiling one. This question was price floor, ma'am. In the
Yeah.
price ceiling again, ma'am, we will get a surplus of 150, and the transaction there again, if we have to calculate this quantity traded, will be that QD was 350 and QS was 200. So again, the quantity traded will be 200 only, na, ma'am.
Yeah. Because they want 350, but you can supply only 200. So then you can only sell what you have. You will always take the lower quantity as a general rule, just from common sense.
Ma'am,
People
in
want
this,
350, but only if 200 is only available in the market, then only 200 can be sold because there's a shortage.
ma'am, in the same question, question number 6, ma'am, can you open the slides, please?
1 minute. 6. Okay. This one?
Yes, ma'am. Ma'am, in
Yes.
this, we had calculated, if you go to your solution, ma'am, question 6 is the question, ma'am.
Yeah.
Yes, ma'am. Now, ma'am, can you scroll up, please?
Question
Ma'am, we
6
go to the
starts here actually.
tot- ma'am, total effect if we go on Q1, ma'am.
Yeah. Hmm.
Ma'am, it is Q1 dash minus Q1 star. That is, ma'am, it's coming as negative. Will it be negative, or ma'am, what do we take it as?
No, it will be negative only. A lot of times the effect will be negative. If price is increasing, is it that surprising that the quantity is decreasing?
Ma'am, thereafter, ma'am, what you try to explain, I just couldn't understand this, ma'am. Can
So
you
what I
take
was
up from here?
explaining, yeah, what I was explaining is that you have calculated the substitution effect from here, from E1 to E star is the substitution effect. From E
Yes,
star to
ma'am.
E2 is income effect, right? Income effect is not easy to calculate directly. So we first calculate substitution effect from E1 to E star, and E star to E2, you calculate the income effect. After you have
Okay, ma'am.
calculated the value of E star, right? You compute the value of E star. So to compute the value of E star, you will need to hold utility constant. So depending on whatever form of function you are given or whatever values you are given, you will calculate the quantity of, uh, E star. good 1 at E star using the condition that utility is held constant. So if utility is held constant, you have to remember that the income will be increased. Whatever the budget constraint is given, I don't remember what the value was, but whatever the value was, that will not be the actual value of the budget at that point at E star. Budget will be something more, right? But in this particular case, I don't think you needed to calculate the budget because you can just directly calculate the value of Q1 of good 1 at E star. And from E star to E2, if you get any difference in the value of Q1, because you know Q1 value at E star and you know Q1 value at E2. You just take the difference between the two, you get income effect. The way this question was framed, there was no difference in the value of Q1 from E star to E2 because in this case, what you were getting was that Q1 was coming out to be just a ratio of the prices. And there is no difference in prices from E star and E2. That is maybe something that was confusing you.
Roger, ma'am. I got it, ma'am. Ma'am,
Yeah.
one more small doubt, ma'am. Ma'am, in the case of monopoly, now, ma'am, when the
Can
tax is
I
imposed,
unshare this? This is not
yes, ma'am. Yes, ma'am.
okay. Yeah.
Ma'am, in case of monopoly, if the tax is imposed, now, ma'am, that
Okay.
tax, it the monopolist can directly transfer it to the consumer and also
Mhm.
get a markup on it.
Hmm.
Am I right, ma'am, in what I just said?
Yes. So the thing is that in the case of a monopoly, because there is no set supply function, right? So based on whatever tax the firm is being just whatever tax is being imposed on the firm can choose its quantity and its price uh, to adjust accordingly. Because the firm is setting both quantity and price. That is the important thing to remember in the case of a monopoly. Because the firm has the freedom to choose both Q and P in the case of tax also. I mean, again, depending on the question, the values may come out to be whatever the case may be. But as a general rule, imposing of a tax in the case of a monopoly doesn't necessarily lower the profit of the producer.
Ma'am, basically, in monopoly, the complete tax will be borne by the consumer, ma'am.
Yes, but what I'm trying to say is that in see the thing is you guys have taken very simple functions for your examples. In certain examples, it may be a little more complex, it may be a little bit different. But what I'm trying to say is that the firm has the choice to choose its price and its quantity. So it can adjust the price in a way that the consumer definitely bears the tax, but it can also find a way to adjust its price and quantity so there is no loss of revenue for the firm.
Ma'am, because in this week's ma'am assignment, there is a last question which is actually ma'am
Okay.
confusing me.
I can't answer a
I
question
know
before
that.
its due date.
I know. But
So,
ma'am, if
yeah.
you just see the options, if you can just explain what options are actually saying without giving the answer, ma'am.
Um,
If you want, I can read out to you, ma'am.
no, I can have it open in front of me. Yeah, I can't explain this more than that because if I do, it will sort of give away the answer. But I think whatever I have said should be able to answer. If you just sit and think about it, or if you look at one of the solved examples in one of the books. There are several
Roger.
solved examples of taxes in Perloff. I think it's there in Pindike and Rubenfield also. I don't remember, but it's definitely there in Perloff. So I think if you look at one of the solved examples with taxation in a monopoly in Perloff, you'll probably get the answer.
Roger, ma'am.
Okay, there are several questions on the chat. What's the price? I'm not understanding the question. Is the price given from where MC cuts MR or the price corresponding to Q star on the demand curve? I don't remember this video. You're saying reference video 130, but I will have to open the video. Like I watch like 30 videos in a week. How do I remember which video has what? So I don't remember the video which you're referring to, but it will be you're asking in the case of a monopoly, right? In the case of a monopoly, you will always have marginal revenue equal to marginal cost. That is how you decide uh, the output level and the price. Does that help you? Okay, somebody else is asking E1 plus E is less than 1, E greater than 1, and elasticity of demand. Okay, then let me just go back to that curve which I was sharing earlier. So this is the basic diagram for price elasticity of demand. This is a general case. This is not the case of monopoly or competition or anything. This is actually from week 3. Week 3 is your basic demand and supply. So you remember total revenue is equal to P into Q, right? At epsilon, now see, you have to remember that P into Q are not parameters here. They're functions, okay? Either you will have Q as, I don't know why this thing is glitching like this. Something seriously wrong. It's no matter what the take, it's coming out to be very clean. Anyway, so here either Q will be a function of P or this is a demand function, okay? Or P will be a function of Q, which is inverse demand function. So when you say total revenue equals P into Q, please remember that either P is a function of Q or Q is a function of P, because when I put epsilon equal to 1, people assume P is equal to Q, like, numerically like that. It's not like that. You will have, say, suppose Q is equal to 100. Suppose Q is equal to 100 by P, something like that, right? Then at the point of epsilon equal to 1, you will not have P equal to Q. So first of all, get that idea out of your head, because I think some people get that confusion. Second thing is epsilon is equal to dq by dp upon q by p. Many people forget this denominator part, which means that, say suppose in this case, I take dq by dp, it is minus 100 by p square. And this epsilon is equal to minus 100 by p square upon q. Okay, q, let's plug in the value of q, 100 by p divided by p. So this becomes p square. In this case, actually, it is coming out to be 1, but it will not always be this case, right? I'm just showing you how it is calculated. Now let's come back to here. If it is, say, suppose it is not 100 by p, it is 100 minus p, then the whole calculation changes. So that is the first thing you need to understand. Secondly, in this diagram, I have tried to explain pictorially what happens when epsilon is greater than 1 and when epsilon is less than 1. So in this case, if you just look at it geometrically, if you move to the side, on this side, if you move this side, what is happening is price is increasing and quantity is decreasing. So say suppose you move to this point here where I made that blue box, your revenue is increasing by this blue box. This blue box is the increase in the revenue, and this whole part, this white box, is the decrease in revenue. So what do you think is happening? Revenue is decreasing, right? Here, at least in this particular case, we're talking about epsilon is numerically equal to 1 or greater than 1 or less than 1. Okay, right? I just wanted to keep it a bit clean. That's why I've not included the sign here, but When we're talking about 1 and less than 1 and greater than 1, we're talking about mod. So let's take this as mod here. This is just to explain it diagrammatically. So if I put it in negative, then also people get confused. Anyway, so when epsilon is greater than 1, an increase in price or a decrease in quantity basically leads to loss of revenue. When epsilon is less than 1, Q1, this is what I was trying to draw at that time actually. Say suppose this is the point where you are. So this is your price P1, this is quantity Q1. Now you are gaining this much, okay? This much revenue is gained from, you're deviating from Q, okay? You're deviating from Q and from P. What is happening? If you're moving in this region, what is happening? Price is decreasing and quantity is increasing. So here you have gained this whole purple triangle. Now let me find some other color to use. It's yellow. This is red. This is red. And from here, this whole part is lost. So again, in this region, as your quantity increases, your revenue is decreasing, not increasing. Whereas in this region, as your price increases and quantity decreases, your revenue is decreasing. Again, I mean, I know it sounds a bit confusing, which is kind of why this diagram also gets a bit messy, and I didn't draw the whole scenario. Oops. Let's delete this part because it makes the diagram a bit messy. But if you try to rationalize it in your head, what exactly elasticity means when it is greater than 1, it is less than 1. Just in simple intuition terms, elasticity means how willing are you to change your demand when the price changes. And what happens to the revenue when elasticity is greater than or less than 1. So there are two parts of it. First part is what is the user, where does the user stand in the price elasticity of demand. So in the case of the users, if you're talking about the demand function, because we're talking about the elasticity of demand here, if the elasticity of demand is very high numerically, if it is very high, say suppose it is minus 25 or something like that, or mod epsilon, say suppose is 10, then that just means that as soon as the price changes, you will switch to something else. You are not going to adjust to price changes. That is what it means from the consumer side. And if the price elasticity of demand is like 0.05 or something, it means it's almost inelastic, meaning that if price changes also, you're not that willing to budge, not that willing to shift from buying that particular good. This particular diagram is talking about what happens to the revenue with some change in elasticity. So does that answer your question? I think that is what you wanted me to explain, the basic intuition. Okay, I don't know if he's still there, but I think I have answered it. Okay, if you still have some doubts, you can post it on the discussion forum. I will keep looking at the discussion forum and I will answer you on the discussion forum if you still have something left. Inelastic and elastic is in terms of 1 or 0. So E is equal to 1 is unitary elastic, E greater than 1 is elastic, E less than 1 is inelastic. Actually, whatever you're asking me, I mean, I can explain, but all of this is already covered in your lectures. And if you are still confused, I would recommend you read this part from Perloff. It is explained pretty well in Perloff. Because sometimes it just helps to switch the medium instead of somebody explaining it. Reading might also help. So please read this part on in Perloff. I think it is a chapter on demand, one of the first two chapters, chapters 2 or 3 or something. Okay, I'm really tired now. So if there are any other questions, I will answer it on the group discussion forum. And sign positive or negative will not change in elastic or elastic. Okay, hang on. So I will post a handout for you guys on elasticity and you can read that out. Okay. I think because you're asking me a whole series of questions, so it is just better if I just post a brief handout and explanation on elasticity of demand. Okay. So I will end the class here today because I have overshot the time now. It's already 8:21 and I need to go somewhere. And this is the last class, so we'll not have more lectures or more, more tutorials. But if you still have questions, you can post it on the discussion forum. I will answer your questions. And for those of you who are writing the final exam, all the best for the exam. And for those of you who are not, well, all the best for whatever you're pursuing. I think in the next run of NPTEL, there is another course by Professor Vimal on game theory. If you like, you should totally attend that course also. It's a really good course. It will help you understand game theory really well as applied to economics because there's like a whole lot of applications of game theory, but its applications in economics are quite interesting. So anyway, it was really nice doing this class. It was a great refresher for me also for microeconomics. And I think my email is already there in all the slides, etc. If you need to, you can anyways email me with your questions. Okay, thank you everyone. Thanks for joining all the sessions and I will log off.
Thank you a lot,
Okay.
ma'am.
Yeah, okay, thanks everyone.